9.1, example 6. In this example, we're going to look at finding a power series for the function ln of 1 plus x. So we know that 1 over 1 plus x is equal to 1 minus negative x. And we know that the power series for 1 over 1 minus x is 1 plus x squared plus x cubed plus dot dot dot. So if you replace that with a negative x, you get this. You just put a negative x everywhere, and you get this power series. Okay, so that's going to come in handy in a second. Okay, so there is something we need to remember about ln of x. So if we have f of x equals ln of 1 plus x, and we do the derivative of both sides, so if we take the derivative of both sides, then we get that f prime of x is equal to 1 over 1 plus x, which if you notice, we have here and here. Okay, so that means that if we have f of x equals 1 over 1 plus x, and we integrate both sides with respect to x, so then we get that capital F of x is equal to ln of 1 plus x. And the whole idea here is to see a relationship to something you know. Okay, so when we look at this, we're going to go, okay, let's start with what we know and work to get what we want. So let's start with the fact that 1 over 1 plus x is equal to 1 over 1 minus negative x, because you want it in the form of 1 over 1 minus. And then the inside is your r, which is going to be 1 plus negative x to the 1 plus negative x squared plus negative x cubed plus dot 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 plus negative x to the n. Okay, so we have 1 over 1 plus x is equal to 1 minus x plus x squared minus x cubed plus dot 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 plus negative 1 to the n x to the n. Okay, so now what we're going to do is we're going to integrate both sides. And so we get that this is ln of 1 plus x equals x minus x squared over 2 plus x cubed over 3 minus x to the 4th over 4 plus dot 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 plus, and this is going to be negative 1 to the n to the power x to the power of n plus 1 divided by n plus 1 plus dot dot dot. And that's it. And so this is called term-by-term integration. It works very, very similarly to the term-by-term differentiation, except instead of taking a derivative, we're now doing an integral. And then from this, we also get a theorem which says that if a power series f of x converges for an x minus a which is less than r value, so the absolute value of the inside is less than r, then the derivative and the integral also converge at that a value.